Hello, hello, hello. See how we do. Let's give it a minute here. Check the stream health. Make sure everything is functioning. So today looks good. Functioning. Yeah, looks good. All right, great, very good. All right, so today we're gonna go ahead and try to do 4 hours of LeetCode. All right, we'll just see how it goes. Yeah, I suppose it's fine. Is there anything else I want to say here? No, there's not much to say. We'll just get going. We'll just do what I can. Do 4 hours worth. See how this goes. All right. So, balanced binary search tree. Given the root of a binary search tree, return a balanced binary search tree with the same node values. If there is more than one answer, return any of them. Binary search trees balance the depth of any of the two subtrees. Every node never differs by more than one. Okay. So 1, 2, 3, 4 becomes 1, 2, 3, 4. 3, 1, 4, 2. It's another balanced binary search tree. All right, so I don't actually know this offhand how to do this. Only 10,000 nodes. Well, I mean, one simple approach, and this is just thinking off the top of my head, would be to basically split the binary search tree into a left subtree and a right subtree, and then rebalance those. So the idea could be to, I'm sure there's like a standard approach to this, but okay, hold on. Okay, it's starting to buffer here. Just give it a minute. Let's see. So today, starting to buffer here. Okay. It's buffering. Might need to restart the stream. I'll come back to that in a minute. So the basic idea might be we could do this recursively. We could take the left subtree and the right subtree, their sizes, and if they're unbalanced, if the size is unbalanced, then we're going to balance both of them recursively. First we balance both of them recursively, and then we take actually maybe a better way to do it. Well, it's a search tree, so that's a little more complex. It's not just a binary tree; it's a search tree, which is a little bit more involved. I would say I'm sure. So there's probably like a standardized algorithm you could use for this. I'm just thinking if there's something I can come up with that's a little more, like a more immediate thing. Yeah, I actually don't know this offhand. Also, I think stream health is good. Okay, stream is healthy. All right, that's good. I'm not sure. Actually, I'm not sure about this one. Maybe I gotta think about this. So, I mean, you can count the left subtree and the right subtree. The problem with, if I just take what's in the right subtree and I do some operation to it and then move some of the elements to the left subtree. So let's say in this case, there's 3 in the right subtree and 0 in the left. and I can move 2 elements in the right subtree to the left. The problem with that, with a binary search tree, at least in this case, is that these elements in the right subtree don't belong in the left subtree because they're larger than this parent node. And so that approach doesn't quite work, at least not in that way. Now, one way of doing that is to quote unquote split. So I can look at this right subtree and see, okay, I can maybe move this root node down to the left subtree of that node, promote this to the root node, and move this one down. And that would satisfy the condition they're looking for in this case. But that's not really a generalized algorithm, right? That doesn't really work in all cases. It's a little more complex than that. Similarly, if we moved down and promoted this 3 to the root node and demoted the parents into the left subtree, that may be a possibility that I could traverse depending on which side has more elements, I can traverse that part of the tree. So in this case, the right side has more elements. I can traverse that part of the tree and find a node that basically everything that's to the left subtree of that node and is a parent of that node. If I'm going down the right subtree, it would be like, I guess this cut, it would be the ancestors and all of their left subtrees and this left subtree, all that added together, compared to the right subtree, the number of nodes. And if those differ by 1, well, it's not really that they differ by 1, but if they differ by let's say if they differ by a certain amount, a bounded amount, if they differ by a bounded amount, then I can promote this node to the root node, and then all of those nodes can be placed into the left subtree, and then the right subtree can be kept sort of as it is. Now I would need to recursively balance both of these subtrees, but that basic approach I think works. So you'd move down either the left subtree or the right subtree. Now, what's tricky about this is what difference can we, like, what are some of the difference values that are sufficient, right? So it depends on the number of nodes that you're dealing with. Since the levels, I think, can differ only by 1, these don't have to be full trees, but they should be close to full. The depth of the 2 subtrees of every node never differs by more than 1. That basically means that the bottommost level, there is like a clear bottommost level, and every level above the bottommost level is full, and the bottommost level has 1 or more nodes. That's a similar kind of a definition. But the depth never differs by more than 1 of any 2 subtrees. I'm wondering if maybe I should just do rotations node rotations with some recursion. That's maybe another idea. So you could take a look at the maximum of the depth of the two subtrees. Here it's 0, and here it's like 3. And then if they differ by more than 1, then you can do a left rotation or right rotation, which moves the shifts the parent node. They differ by more than 1. Here, actually, another rotation can happen. Believe it or not, 1, 2, 3, 4 also works here. Yeah, I guess you would repeat the rotations until the root and subtree is balanced, and then you can recurse on the two left side subtrees. Yeah, I guess that's fine. Could do that one. That one probably works too. Just do a left rotation or right rotation. I guess that's fine. So balance. This question is a little bit harder for me. I think this was probably more of like a trivia question where I just kind of didn't know the answer offhand. I'm not sure. Okay, so stream is still live. All right, that's good. I'm trying to think about I don't really want to make like excuses. I mean, I guess this was just a harder question for me. We'll just go with that for whatever reason. Okay. Okay. We're going to define a right rotation and left rotation. Yeah, I'm not so sure about this one. I also don't know, I guess the node count or the subtree count, something like that. Wondering about that too. We need to think about that a little bit more as well. I might want to memorize that or put that in a map. I'm not sure. We'll come back to that. Come back to that. Not the depth, but the node count. I guess you could do the depth. That's maybe fine, actually. It's a good question. Okay, we'll do the depth. Yeah, I'm not 100% sure about how I want to do this. I'll think about this a little bit more. So okay, so we're going to take the left subtree's depth and the right subtree's depth. You're going to take the maximum of the two, and then you're going to add 1. And that's how we're going to get the depth of the tree. Okay. And then if you reach a null pointer, an empty child, you return 0. All right, left rotate, right rotate. What we're going to do is rotate to the left is going to take the right child. So our child, left child. We have the right child, we have the left child. When we left rotate, we're going to make the right child the parent. To the previously parent target node. So we would take the parent node Oh, that's awkward. That doesn't really make sense. It only makes sense if that right child doesn't have any children on its left subtree. If it has a child on its left subtree, okay, actually a better way of doing it is the following. Root of the subtree, the leftmost child, left descendant of the or child contains the parent target node as a left subchild. All right, something like this. I don't know if this is quite right, but I'm going to try it. I don't know if this even makes sense. This even works. I mean, part of me thinks it works. I guess this is probably a standard way to do this that I'm just not aware of. Okay, so while LDesk exists and LDesk left exists, we're gonna move all the way down. And then now we're gonna take this LDesk left becomes the target node. And then the target node right is now a null pointer. So we've taken the right child, moved all the way down to the left descendant of the right child, took the root node, moved it down to the left side of that left child, and then it previously was pointing to, this right child was previously pointing to this R child. Okay. So now that's a left rotation, right? We just moved like this. So that becomes the new root. And we return this right child. This becomes the new root. Okay. So that's a left root. We'll call it a left rotate. And then we'll do a right rotate, which is basically the mirrored version, the symmetric version of this. So left child, target left, null child, excuse me, the rightmost right descendant of the L child. So now this way we go left child and all the way down to the right. This is all mirrored. So now this right descendant, left side, right down. Now this gets the root node of the target, becomes its left child. It should be the right child or the left child. No, it's the right child, not the left child. Yeah, now that becomes the right child. And then the target left becomes a null pointer. And we return that left child. So a left rotation and then a right rotation. Right rotation is going to move this way. Okay. Okay. This actually, we're not going to return the root. We're going to return what balance returns. I think. Okay. Now I don't know if this is actually going to work. I guess what I'm going to try to do is say if depth of the left subtree, the first things first. If not target, then we just return null pointer. if the depth of the left subtree we're going to calculate both of these numbers. L depth so if L depth stood absolute value of L depth minus R depth is greater than 1, then not a balanced tree. Rotate and balance. Okay. How's the stream health? So I'm not sure if this algorithm is actually going to work. I'm going to try it. So part of the issue is I'm not sure this is going to be correct if we just do left rotations, right rotations, and recursively try to balance. Part of the issue is that how many nodes get moved from one side to the other? Let's say the balance works recursively. Let's just pretend, suppose, hypothetically, it works recursively. At least the recursion part works, right? If all I do is say, okay, check the left side and the right side, check if it's unbalanced. If it's unbalanced, then we're going to do a rotation, and then we're going to balance each of those parts recursively. I don't think that really works because there are a few issues here. First thing, the rotation that I'm describing doesn't respect no, this doesn't work if I do it this way. This doesn't work. I mean, there's another way to do this. It's pretty straightforward. You could just dump the entire search tree into an array and then create a balanced search tree out of the array. I mean, that's probably the easiest. That's probably what I should have done, quite frankly. I don't know why I'm making this so complicated. I'm making this way more complicated than it needs to be, I think. Oops. Yeah. I'm making this like far more complex than it needs to be. There's a very straightforward way of doing this. Dump entire search tree into an array using an in-order traversal. I think it's a pre-order. Is it pre-order or in-order traversal? Yeah, it's in-order traversal. Convert the sorted array of values to a balanced BST. That's probably the easiest way to do it, quite frankly. So there we go. Dump. It's going to recursively array. Yeah, I probably should have done it this way. Don't actually know how many elements there are going to be. could reserve 10,000 elements. Could do it this way. This kind of works. Okay. This is, yeah, it'll be const. We're gonna say actually maybe better would be like this. Yeah. Left subtree, right subtree, and then we're gonna say pushback. Target, I think. Okay, let's do it this way. Okay. So we dump into the array, and then now we have constant size n. Now we're gonna say iteratively build or recursively build. BST. Balanced auto build BST. Mm-hmm. Actually not sure. Maybe I do. This might be easier. A and B is like indices into the array. This could be pointers instead of indices. But let's keep it simple for now. Okay, so I spent quite a bit of time on this. I think I should have realized I could do it this way sooner and program this sooner. Well, this is kind of an unusual question for me, so. All right. So we're gonna say constant min. It's gonna be a. It's gonna be b minus a. It's gonna be a plus b minus a. It shifted 1. And then we're gonna recurse. So we're gonna say tree node left. It's gonna be recurse on the left side from A to mid. And right, it's gonna recurse on the right side. +1, mid -1. So it's gonna be A to B. And we're gonna return, we're gonna say tree node new root, or yeah, new root is going to be array of mid. We're going to return that new root. And we're also going to say new root left. Yeah, new root left is going to be left. New root right is going to be right. Okay. Hopefully that makes sense. Say if mid is less than 0 or mid is greater than grayed out size. Then we just return a null pointer. Something like this. Zero, and we're going to say array.size minus 1. What does this do? Let's try something like this. Oh, it doesn't have automatic storage duration. Oh no. Cannot be captured. I see. Okay. I think I can access it without capturing it though. I could be wrong. Not sure. Runtime. Okay. Stack Overflow. Okay. Oh, excuse me. I think actually that's what it's supposed to be. There we go. All right. I'm gonna go for it. See how this goes. Yeah, this wouldn't be so bad, I think, if I'm gonna just try it, see what happens. I probably get something wrong here though. Oh, no, got it. Highly efficient solution. Yeah, I mean, I should have solved that a lot quicker, a lot sooner. That was kind of a mistake on my part. That was the stream health, it's okay. Oh, I meant to check the chat sooner. What's up? Hi, how's it going? 42LV88, what's up, Gucci Wampum? Vectors dynamic, Python, trying to set it to 0, sorted, leftover space with zeros. Car really, no trees, accepted. What's up? Yeah, how you guys doing? Howdy. Yeah, pretty good. That was actually a lot easier than I thought it would be. I was trying earlier to like do some fancy like rotating it and all that stuff, but there's no reason to do that. I just dump the thing into a sorted, make it a sorted array, and then just create a tree out of it recursively. I think that's the easiest way to go. Yeah, this just basically it takes the midpoint and then creates two balanced subtrees on the left and right side of the midpoint, with the midpoint becoming the new root. And this actually doesn't allocate new memory, I think, anywhere, which is pretty efficient, except for the initial vector. But because I made that static, it's just one declaration, and clearing it allows me to maintain that memory through all the calls, which is cool. So it like creates that vector and all that memory, and then when I clear it, it still keeps that memory. It just so when the pushback commands are really fast. Yeah, like it's like if I reserve that capacity for the array or the vector, and it's static, so it can be reused in this way. Yeah, it's pretty good. Okay, next. I should be going faster. I mean, that was actually really slow on my part. I actually had thought of that solution previously, but I forgot I thought of it. That was kind of bad on my part. That was bad on my part. I should have like remembered that was the way I wanted to do it. That's definitely like the easiest way to do that. All right, minimum sum of 4-digit number after splitting digits. Positive integer num, 4 digits. Split num into new integers, new 1, new 2, by using the digits found in num. Leading zeros are allowed in new 1, new 2, and all the digits found in num must be used. For example, 2932, following digits 2, 2s, 1, 9, and 1, 3. Some of the possible pairs, new 1, new 2, 2, 2, 9, 3, 2, 3, new 2. Minimum possible sum of new 1 and new 2. Oh, that's interesting. 4 digits. I'm going to use the digits into 2 numbers. Leading zeros are allowed in new 1 and new 2. Okay. So this is pretty straightforward. Because numbers are defined by powers of 10, you're going to try to, in order to minimize this, if you have any of the digits in the 10 to the third power, in other words, if you do a 3-1 split, so there's only a 2-2 split or a 3-1 split. Those are the only ways you can do it. Otherwise, the other one doesn't have a digit at all. It's 0, 4, 3-1, or 2-2. You can't do a 3-1 split because, well, obviously the 0-4 split doesn't work because you don't have 2 numbers. 3-1 split doesn't work because one of the numbers is going to have 10 to the third. The 10 to the third is always going to be larger than any sum of the not necessarily. Actually, some cases the 3-1 split is better. If you have a 0, oh, that's interesting. This is a little bit tricky. There are some cases where the 3-1, I was going to say the 2-2 split's the way to go, and then you could just sort by, normally, not normally, I think most of the time, 2-2 split's the way to go, and you would just sort by the smallest digits. So you want to have in the tens place, the smallest digits. However, there is a case where the 3-digit split may be better. That's only, no, it's not possible. The 3-1 split's never better, because the only time it might be better is if you have the sum of the 2 split can exceed 100, basically, which it can actually go into 3 digits if the sum, but that is only relevant if you're going to put a 1 in front of the 3 digits. And if you have a 1 in the first place, you might as well put that into a 2-digit split. So it'd only be like if you had like 10 and 9, you'd have to have 10 and 90, something like that. And then your sum is, but it would have to be like a 99. Like it'd have to be, I think it'd have to be exactly like 1999. Because if you have anything other than that, then you can use the other digit in the 2 split as the tens place. So let's say 19 and 99, if you added the 2, you would get 118. And so really it's only relevant when the 3-1 potential difference is only relevant when the 2 split can exceed 100. The minimal 2 split can exceed 100. Which actually can happen with an 8 in there too, like a 1989 or something. Like there are actually a few cases where that could happen. But even then, if you do like 100, the problem with that is that if you did like 199, or yeah, it'd have to be something like 199 or 189 or something, like that second large digit in the second place is going to already exceed whatever you have. Like even 1999, for example, you only get up to 118, I think. That 1 you get in that second spot is going to be small compared to what, yeah, so it's not, no. So no. The 1-3 split, I think you can rule out the 1-3. It's a little bit complex to rule it out, prove it, but I'm pretty sure you can prove it. So it's just the 2-2 split, then you just take the two, you just take the, in the tens places, the two smallest numbers. And you're adding them together in the ones place anyway, so it doesn't matter where you put the ones. Yeah, so that's pretty straightforward. So let's just do a toString. Let's do it like the following. So I think we can do it this way. So we're gonna do stood string. Let's actually do it. Let's do it this way. Stood vector int or I'm not sure how to do this. I mean, I'm trying to figure out a way to do this. Let's do array for. Okay. I'm not sure. This is pretty awkward. That's okay. That's okay. All right. Let's just do it 4 times. Let's just hard code it 4 times. Oh, this also should be larger so you can see what I'm doing. Oh, you can. All right, we got 1, 2, 3, 4. Okay, now we have the 4 digits. We're going to sort this. Can I do that? I might be able to, I'm not sure. And then we're going to say return. What the hell do I want with this return? Okay, we're just going to add the sum. So it's going to be 10 times array of 0 plus array of 1 plus 10 times array of 2 plus array of 3. Something like this is my thinking. Yeah, a bit wonky, but not the worst compiler. Okay. It may have to be stood sort. I thought maybe the vector has its own network error. Okay. Let me see, is the stream still healthy? Yeah. Okay. Rechat in a moment. Okay. Wrong answer. Okay. Output 61, expected 52. So I went with 29 and 23. Oh, no. Oops. I did that wrong. Okay, that one. I think it's that simple. I'm going to just go for it. This could be wrong. 0, 5, 2. Can it be all zeros? I'm going to go with this one. I think this is right. Okay. I guess I can't have all zeros. Yeah, I can't have all zeros. Okay. I just want to try some cases before I submit it. I'm not sure if this is the correct answer or not. I didn't really prove it. I kind of like tried to think it through, but actually proving it's a little bit complex. In the interest of time, I don't want to overdo it. I'm just gonna go for it. Stream health. It's healthy. Okay, we got it. All right, not bad. Maybe not the fastest solution. It's okay. It's all right. Maybe I can do. Trying to think if there's a better way to do this. I mean, it's okay. It's all right. Let me try something else. Just do this 4 times. This. About this one. Okay, that's a little bit better on memory. All right. Okay, next one. How am I doing on time? 50 minutes. Yeah, I spent a lot of time on those 2 questions. Spent a lot. That was JavaScript. Okay, transform over each element in the array, integer array, mapping function. Return a new array with a transformation applied to each element. The returned array should be created such that returned array of I is equal to function array of I. Solve without the built-in array map method. Okay. Okay. I mean, I don't know, man. There's a way to do this in JavaScript. Double check this JavaScript. JavaScript for syntax. I don't know. Something like this? I don't really know. I'm not really sure. Oops. Comparable to for auto for in. See if it understands. Append. For in, let key in. Okay. It's not comparable, but it's similar. Values directly, so okay, values directly, alright. Interesting. Push. Okay. Shift, splice, concat, let's do push. I think append is a Python. Runtime error. Oh. Critical issue, property keys. Okay. Of. Okay, there's in and of. Okay. JavaScript's a funny language, man. How is stream health? It's good. Wrong answer. Runtime error. Oh my gosh. Oh, okay. Avoid for in. Okay. Does for of maintain order? I might need to use a raw loop. Why is this wrong? It's not a valid value. Huh. What is going on? Wait, what? The value, the index it resides in? Oh, excuse me. Array of, oh, I see. Array of I. Got it. Got it. I mean, maybe I just keep it simple. Okay. Oh, the for of does maintain order. Okay. Cool. Okay, now it's correct. All right. That was a little bit confusing. I think I just didn't fully read the question. All right, not bad. We'll move on. I don't think this one requires too much expounding. Okay, decompress run length encoded list. Given a list of nums of integers representing a list compressed with run length encoding, consider each adjacent pair of elements, frequency value, nums 2i, nums 2i plus 1. I greater than equal to 0 for each pair. There are frequency elements within with val. Value val concatenate a sublist, concatenate a sublist from left to right to generate the decompressed list. Each adjacent pair frequency value. Oh, I see. Okay. So 1, 2, 3, 4. There's 1, 2, and there's 3 fourths. Okay, got it. Oh, this is cool. Sweet. So just decompressing an RLE. Oh, this is cool. I like this. Maybe I can do the following. Constant size is going to be nums stood filter. Let's see if we can do this. We're going to filter nums on constant x, return x and 1. Wonder if I can do this. So I want to filter on the odd values. So is it odd or even? Even indexed values, I think. Yeah, even indexed values. So we're going to say even indexed values. And then we're going to add them together. Which I don't remember. Let's like filter to summation. Let's see if I can get that. Also, these should probably be larger. Stream health is okay, and chat, okay. Accumulate, 0 plus 20 preferred, accumulate. All right, we'll just accumulate that. filtered. Okay. We're going to say auto filtered. Not sure how good that is to do. We're going to say stood accumulate built. I'm going to just say odd or yeah. We'll say frequency. Okay. Reserve. There we go. Now we can say for each pair. I think it's probably easier to just do it this way. Let's do it this way. We're gonna say constant frequency amount is gonna be nums I and constant value nums of I plus 1. Something like this. Just say position. Something like this. I'm not sure if that was the best way to do it, but it's one way of doing things. Check the stream health again. Seems healthy. Filter standard ranges views filter. Yeah. I mean, do I need to put all that in there? Runs up error. Okay. Interesting. What? Oh. Right. That might be. That's probably why. Okay. Let's see. Doing this wrong. Hmm. What size am I getting here? Size 2. No, should be 3. It should be 3. Okay, that's wrong. Oh, shucks. That's wrong. Okay, got it. It's not every odd number or even number, it's every odd index or even index. Oh, whoops. Alright, I'll do filter on index. I don't know what I was thinking there. Yeah, I'm actually not so sure about that one. Hmm. Yeah, it's probably just overkill. Thought I could be clever here, but it's probably not. It's probably not worth it. Yeah. Accumulate and a lambda that tracks the index. Explicit loops clearer and faster. Yeah. Yeah, it's probably a little more than is required. I spent too much time on this question, I think. All right. Oh, some buffering going on now. Okay. This came out all right. What are you coding for? What's up? Tests first. Hi, log please. Is your camera having a little delay or my internet's bad? No, it's hello everybody. It's my I think my what do you call that? My bit rate's falling. Let's give it a minute. Yeah, my internet connection's not perfect. It's not as good as I'd like it to be. Unfortunately, it's gonna be like that for a little while. It looks like it's still buffering. Yeah, it might be a little bit. You're pretty fast. Give some tips from beginner to DSA. What's up? Able to join your live session today. Hey, welcome, welcome. I appreciate it. Yeah, I've been practicing for a while. Maybe like uh since like 2013 is really when I started, something like that. I created my LeetCode account like a few years later though. Um, it's been a while. I mean, technically, I've been doing it longer than that because I did have a data structures class at university. Um, See that one, I should have done that one more quickly. I think I think I spent too much time on it. But tips, I would say, practice makes perfect. Practice makes perfect, and don't waste too much time on things you don't know how to solve. A lot of this stuff is not new research. Like some of it's based off of research that'll take you way too long to figure out on your own. We're talking about very hard questions. Like the easier ones, you just practice, you'll get better. But the really hard questions, a lot of them are based off of results that are a little bit too challenging, typically for an individual to come up with on their own. So like a couple of examples I can give would be like, or one example is like the matrix tree theorem is something they teach. I think at MIT they teach that, but like allegedly that took like all of humanity like 100 years to come up with, and so like if you try to come up with it on your own, like it's just gonna take you too long. So there's like stuff that you'll be like you'll get like hard stopped if you don't um like look up the uh the algorithm that's involved. Um yeah, that would be like one of my bigger tips. Sum of values indices with k bits, set bits. Okay, so how are we doing on the see if it's still buffering? Okay, it's not buffering. Well, it might be buffering a little bit, but not as much now. Zero indexed integer array nums and an integer k. When return an integer that denotes the sum of elements in nums whose corresponding indices have exactly k set bits in their binary representation. The set bits in an integer are the ones present when it is in binary. Written in binary. Example, the binary representation of 21 is 10101, which has 3 set bits. Values at indices with k set bits. Zero index integer array nums. Integer k, integer that denotes the sum of elements in nums with corresponding indices of exactly k set bits in their binary representation. Okay, I think I understand. Oh, the corresponding indices. Oh, that's interesting. So the number of bits in the, okay, I think I understand. So we're gonna use a transform reduce. And we're gonna do something kind of fancy here. So ready. Also, my computer's lagging a bit here. Computer sometimes does that. All right, we're gonna do nums begin, nums end, and we're gonna use a special int index, and we're gonna say 0. It's gonna be so std plus, and we're gonna say transform is gonna be a bit fancy. So we're gonna say index plus plus, say if return result or ret results fine too. Say results equals 0. Say if the x or val if the index, and we're gonna say you could do pop count, I think. In C++ now has this pop count is equal to k, then we're going to set result to value, increment the index, and return the result as part of the transformation. So we're going to turn it, it's going to turn into 0, or it's going to basically be zeroed out, and we're going to add everything together. Do it that way, I think, is how we're going to do it. Pop count. Okay. I don't know if we have pop count. We could use there's one of these, I think, that works. But oh yeah, it's the C++ 17, I think. Can use bit set count. That works. Yeah, this one is bit set count. This one I think is a little more of the right way to go. Okay, we're gonna go for it. Stream health. And there we go. That's pretty good. That's pretty good. I like that. I like that approach. Are you a genius? No. No. I appreciate that though. Couldn't even do climb stairs half more than 1 hour there. Stream phone or tablet something. It's a laptop. It's just the internet connection I have. Where do you work, man? Right now, actually, I work at Hello, what's up? What's up, G Cathari? Let me answer in a second. Hold on, let me just see. Let's do the next question. So the climbing stairs one's not too bad. I think that's probably one of the first DP questions you work on. Same string. Wait a second. Of the array. Oh, string arrays. Oh, interesting. The elements concatenated in order forms the string. Okay. There are ways of doing this, I guess. There are at least a couple. I mean, one way is just concatenate, like just join the strings and then compare them directly. Another way is to like just iterate through the arrays. So let's try iterating through the arrays. See how that goes. Give me 1 second, folks. False. Oh no, we'll say it's true, and then return check. Let me answer the questions. Oh yeah, I currently work in fast food, and I'm thinking about starting my own company. I don't really like working for a lot of the tech companies. They kind of do a lot of things I kind of dislike. What do you suggest when the logic doesn't click? There are a lot of different reasons for that. So it could be sometimes the answers are just not correct, and they just happen to work on the test cases, which means the logic is just not correct. But sometimes the algorithms are just a little bit too difficult that they're using, and you've got to look up the algorithm that's being used. Okay, so I would say let's try something kind of fancy here. We're gonna keep track of 4 different iterators. Ready for this? Let's try this. Let's do auto p1 word 1 again, and p2 is word 2 Okay. And then we're gonna say integers I0, j0. And we're gonna say p1 is not equal to word 1.end, and p2 is not equal to 2.end. Okay, and then we're gonna say word 1, or no, p1 dereference p1 of I equals dereference p2 j. And we're going to say if they're not equal, then we're going to return false. So actually, I don't need this. I think this will work. Let's try this. If we get through it, we return true. If we don't, return false. Oh, no. Actually, we got to make sure we got through both. Yeah, I got to make sure we got through both. This is kind of this is maybe not the best way to do this, but this is maybe one way of doing it. So if they're equal, we're going to increment I, we're going to increment j. So if I is greater than p1 size, I think it's size in C++, then p1, we increment p1. We do the same thing for p2. So then I is back to 0. And if j, if it's got to be greater than or equal. And the same thing here. Oops. Okay, what happens if I do this? This is a bit odd, but I want to try it, see how this works. Compiler, okay, pointer operand, p1. So sometimes you've got to do something like this. There might be a better way to do that, but I'm going to do that for now. Okay. I'm going to go for it. This might be wrong, but I'm just going to go for it. There's probably some subtle thing that I missed here. Got it. Okay, not bad. Not bad. Yeah, I like that. I like that approach. It's cool. Submit again. How are we doing on time? I got another hour, a few more hours. Stream is healthy, and how are we doing on chat? What's up, chat? All Indians are watching a stream at 1 a.m. here. Yes, bro. What's up? Yeah, that would be my suggestion, is to address your question before. If the logic doesn't quite click, sometimes you just need to spend more time practicing reading it. Sometimes the answer itself is just wrong, and there's no real way to like understand it. And then sometimes, or not that you can't understand it, but you just have to like understand that it's wrong. And then the other one is sometimes they're too hard, and like they're things that it's just gonna take you an eternity to learn it on your own. And you gotta just look up the answer. Well, not the answer, but to look up the algorithm. Like I said, there's quite a few of like the competitive programming algorithms that are like the KMP algorithm, for example, the Knuth Morris Pratt. That one's like, you're not going to come up with that on your own typically. It's very unlikely. You can come up with something that's close on your own, but it's a pretty hard one to come up with on your own. Integer array nums, an integer digit, turn the total number of digit times digit appears in the decimal representation of all elements at nums. Total number of times digit appears in the decimal representation of all elements at nums. Okay. Count the number of times that particular digit shows up. Alright, I mean, there are a few ways to do this. Yeah, I mean, probably easy ways, just... So we're going to do the following. So for constant x nums, results, we're gonna have a while, unless can the digit be 0? That would be awkward. Oh, it can be 0. Oh, okay. Ooh, it's edge case. Oh man. Oh. Yeah. Um. Okay, we're gonna just do it this way. X mod 10. Something like this, I think. Let's go with that. Go, 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 go. Oh, it shouldn't be constant. Whoops. The one situation where I don't want that to be constant. Alright, let's go for it. There might be something wrong here. I could have made a mistake. Okay, got it. Sweet. Not bad. Alright, next. Go, 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 go. Sort the students by their kth score. Alright, there's a class with m students and n exams. You're given a 0-indexed m by n integer matrix score, where each row represents one student score of ij. Denotes the score the ith student got in the jth exam. The matrix score contains distinct integers only. You are also given integer k. Sort the students by their scores in the kth 0-indexed exam from the highest to the lowest in the matrix after sorting it. Okay, I gotta read this a couple times to understand this. Let me see. Can you do it in JavaScript? Unfortunately, I very rarely program in JavaScript. Oops. Ah. Chat. There we go. Asmit is commented on your videos as well. Oh gosh. I have no comment. Oh no. Oh, stream died. All right. Did it work? Did it work? Is it streaming? Are we back? Let's see. Hold on. Okay, are we back? Are we live? Okay, it says it's healthy. Oh man, oh, that was brutal. Dang. Okay, stream health is excellent. Whew. Alright, how's chat doing? Right. Let me just make sure we're okay here. Give me one more second. Can I refresh this? Can I restart this? Hold on. I'm not sure what happened. I think my... Let's see, hold on. I'm not sure what happened. Okay, we're good, we're in good shape. I think he wants to meet me. That's fun. Okay. I appreciate that. All right, I think we're okay. Let me just, yeah, we'll leave this. Okay, that's good. All right. Okay. N by N, M students, N exams, N by N matrix. Each row represents one student. A score denotes the score ith student got the jth exam. Distinct integers only. Integer k, sort the students by their scores in the kth exam from the highest to lowest. Okay. Sort the rows by the score in the kth exam. Interesting. So I think the way to do this is use a std sort. Whoops, not like this. Okay, we're going to return score. It's going to be score begin, score end, and it's going to be a transform of the return index k. I think it's std vector int v1, v2. I probably should have used auto for this. And we want to v1 less than v2. I think it's just v1 of k less than v2 of k. I think that's it. I don't know if there's anything else to it. I think that's all we need. Unless I'm mistaken. Wrong answer. Okay, not quite. Expected. Is it from highest to lowest or lowest to highest? Oh, the highest to lowest. Okay, all the way around. Okay, let's see. Okay, there we go. Nice, not bad. Stream health. Okay, stream health is good. And let's do next question. Not bad. Okay. Write a solution to reshape the data so that each row represents sales data for a product in a specific quarter. The result format is in the following example. Okay. Specific quarter. Is this pandas only? This might be pandas only. Okay, it's not SQL. Sometimes it's SQL, sometimes it's only pandas. Sales of a product in a quarter. So product quarter 1, 2, and 3, and 4. Okay. There's the columns. Each row represents sales data for a product in a specific quarter. So example 1, quarter 1, 2, 3, 4. Product quarter sales. Okay. I think I understand. So they want a quarter column and the sales for that quarter. All right. Wide to long format. Okay. What do they call this? They call it an object. Type object. Object or string? I don't use pandas that much. So pandas object type versus string type. Data frame. And I want I have to think about this a little bit more. So I'm not super familiar with pandas. That's how we're doing on Stream Health. Stream is healthy. That's good. Let's try again. Yeah, that's what I need to get a little more information about. They differ: type, safety, performance, handling, missing values. Mixed types, no enforcement, string only. Okay, so I guess I could use string. All right. Okay. I'd like to reshape the data frame. What are some routines exposed to me? So we're gonna want product quarter sales. Let's see. I'm not entirely sure how I would do this. Pivot table, long to wide, column values as headers. Aggregation for duplicate keys, wide to long. Oh, interesting. Okay. Columns into rows. Oh, all right. Okay. Let's consider melt, but let's not use the basic routine. Go ahead and implement this directly. Let's consider just creating basic data frame. What am I doing? Like, I understand like SQL syntax, but I'm not really familiar with Panda syntax. Okay. df data frame, list of lists. Okay. NumPy array. Empty data frame. Okay. How might fill data frame with data? What if I want to use data from another data frame? Spend some time doing some learning here. Copy entire data frame. Copy specific columns. Fill missing values. Merge on keys. Direct assignment. Dot copy to avoid unintended reference sharing. Okay. Okay, so excuse me, in this case, so we're gonna have product quarter and sales is let's create the data frame. So PD data frame. Could do results or just df. It's fine. And then we want PD data frame, and we'll just do columns. One, two, product, quarter, sales. Okay, so this will be an empty data frame with the right columns, but not the right information. Okay. And now I want to okay. Would it reasonable create empty data frame and then fill it data from another? Okay, location value. Copy specific columns. Okay. Well, okay, let me go ahead, attempt to process each row of a data frame, and for each column frame, want to create another row in a target data frame. Does that make sense? The idea performs something similar to the melt routine. Yeah, I'm not entirely sure. Yeah, so I would see umbrella Q1, Q2, Q3, Q4, and then I would create each of these rows. So, let's see. Each column except the identifier columns into a row, converting a wide format to a long format. So ID vars, ID column, var name variable, value. Columns keep as identifiers. Each original data column becomes a new row with its name and variable and its value. Interesting. Ooh, excuse me, efficiently reshapes without manual reference. Okay. I would also like to attempt to do this a bit more manually. So let's try the melt one first and see what happens. df.melt ID vars for name. ID vars, var name, value name. I used to work on electronic trading systems, for those of you who are interested. Some folks that ask me where I work. Var name equals variable. Quarter. And then value. Original data column becomes a new row with its name and variable and its value and value. Uh-huh. Quarter. And then sales. What does this do? Oh. Okay. Wow. I did forget a comma. Let me check the health. Bro, try potted once. What's up, D-Rush? What is potted? What is that? Oh no. Oh, it's gotta be equal to equals. Of course. Also let's check stream health. It's good. Stream health is good. So yeah, I mean the melt routine, basic melt routine works, but I don't want to use that if I can avoid it. Well, let's submit that so that way we're correct. But that's not what I want to do. I want to try to do this in a way that's a little more like, I'm not sure that this is what they wanted me to do, you know? Not sure if this is quite what they want. Okay, manual approaches using loops. Example data frame. Manual melt for each index row in df it rows. For column in AB non-ID columns. Result on append. Interesting. ID variable value. Oh, okay, like that. Efficient alternative using list comprehension. Mouth is more efficient and readable. Okay. So we could use list comprehensions, but another way is let's do manual melt. Okay. So result. Okay. What does this say for the index and the row and df it rows? It's row in port it rows. Okay. So we can get the index and the row and in the iterate through rows. Okay. For column in AB. Product. So it's non-ID columns. Okay. So it's going to be quarter 1, quarter 2, let's see, quarter one, quarter two, quarter three. Quarter four. Okay. For each of these columns, so we're going to say for each index row, iterating through the rows, for each column in those rows. Interesting. We're going to go ahead and append. Looks like we don't need the IX here. But this will give us the index anyway. We just need the row. Then we just say result.append. And then we return this result. Oh no, we create a data frame out of that result. Okay. Okay, interesting. Huh. All right. This is going to be ID row product row product. I'm not sure what the ID is going to be. R. Okay. And then the other two are variable and value, which is quarter. And then value, which is sales. And this is a map. Quarter. So I think it's going to be C and sales of R of C. Something like this. Key error, quarter one. Okay. Oh, it's underscore one. Yeah, okay. See how we're doing. Chat and YouTube, bro. What's up, Goggle Cat? Welcome. Hello. Howdy. How we doing on the stream health? Looks okay. Oh, error. Oh, hold on. All right, let's see. Let's give it a moment. I'll have to double check in a minute. All right, the stream might be stream might start buffering. Wrong answer. Okay. Come back to that in a moment. Okay. I wonder if I can refresh this. Maybe a moment here. Let me maybe refresh this, see what happens. Reload. I think this is gonna be okay. So okay, stream health. Let's see. Let's check the stream health. It says error. Yeah, it might start buffering. Let me see how bad it is. Okay, stream health. Let's see. It seems okay. All right. Oh, it looks like they want a specific format, huh? Oh, they're not okay with me doing it this way, huh? Ooh. All right. So this, I think this is a manual melt, but this is not what they're looking for. Interesting. You could do it the other way around. I mean, this works too, right? I think this also works. Yeah, there we go. That's correct. Okay. So that's the manual melt. I think I understand it. Then how about the other? So they said a list comprehension could work too. So what does that look like? That create the DF frame using a list comprehension. Okay. Let's see. Okay, this is gonna be like so, similar. So I think it's the list comprehension basically. It's like the in reverse. It's not going to be append. It's just going to be this map directly. That's going to be 4C in this, 4IXR in reported row. Something like this, I think. I'm a little more familiar with list comprehensions. Excuse me. So hopefully that, yeah, there we go. That's what the list comprehension looks like. So that was a little bit easier for me to program. Okay, so, all right. So that's what a manual melt looks like. And then you can also use the melt routine. And this is the melt syntax looks like here. And then this is what the manual melt syntax with a list comprehension would look like. And then you could also use, this probably should just be like this. Interesting. This is how you could use like loops in Python to do this. So that's cool. I mean, yeah, pandas is pretty nifty. Pretty nifty. Let's go to the next question. So, let's also just check the stream health, make sure that's okay. We're okay. Yeah, it's good now. Nice. Sweet. Sweet. So, given the root of sum of nodes with even valued grandparent, given the root of a binary tree, return the sum of values of nodes with an even valued grandparent, even if there are no nodes with an even valued grandparent, return 0. Grandparent of a node is the parent of its parent if it exists. Even valued grandparent. Okay, that's interesting. So this is the grandparent. Has even this value of 6. And this is a grandparent even value of 8. Okay, that's peculiar. So getting the grandparent. So we definitely want to use a recursion here. Use the DFS. And I think we just keep track of a couple of nodes. Just thinking here. Do I want to just have like a GP node? I mean, I guess I could. BGP. Yeah. I mean, this kind of works. Let's do parent, grandparent. Sure, why not? I suppose this is fine. Just make sure this fits in the integer. It's 100 nodes, 10,000 nodes at most 100 values. So it fits in those results. Okay. Let's see. All right. So we're going to say, okay, so if not target, and return. If G parent and G parent value and 1, that's odd, even, result plus equals target value. Then we're going to say I'm not sure if this makes sense actually. Wondering if a level or a traversal is better. I mean, yeah, it's a little awkward. Let's just do this. Let's just keep it simple. This is too awkward. We're gonna just keep it simple. Okay. All right, so root node, yeah, root. Okay. Oh, and I need one more item. Forgot. I need something else here. Excuse me. Okay. Now we're going to call recursively. Say target left, and the parent is going to be the target, and the grandparent is going to be the parent. And we're going to call right in a similar way. Yeah, I think that's all I need to do. Actually, I think it's very simple if I do it that way. Wrong. Oh, compiler. Wait. Yeah, it's fine. Stream health. That's good. I think we just go for it. I think that's actually very straightforward, this one. Yeah, not bad. That's pretty good. That's a pretty straightforward solution. All right. Next. How am I doing on time? It's been almost 2 hours now. Okay, that's pretty good. I spent a lot of time on some of the questions. Positive integer n, find the sum of all integers in the range 1 to n inclusive that are divisible by 3, 5, or 7. Integer denoting the sum of all numbers in the range can satisfy constraint. Okay, this is inclusion exclusion principle, so it's going to be it's going to be the sum of. So you ready for this? Okay, 3 different things. It's going to be n divided by 3 plus n divided by 5 plus n divided by 7. These are the different values that are oh wait. Oh wait, you're gonna multiply by 3. No. Excuse me. Okay, hold on. Const combination. This is kind of wrong. I think it's gonna be a combination of n over 3, combination of n over 5, combination of n over 7. It's a bit complicated. So inclusion exclusion principle basically says the things that are divisible by are multiples of 3, multiples of 5, multiples of 7. You're going to take the sum of all of those values directly. So just divisible by 3, just a multiple of 5, just a multiple of 3, just a multiple of 7. Then subtract the ones that are combinations of just 2, and then add combinations of all 3. So a multiple of 3, 5, and 7. And then the ones that are combinations of just 2 are going to be, so 3 and 5, 3 and 7, 5 and 7. Those are going to subtract. So 3 choose 1 is 3, 3 choose 2 is 3, and then 3 choose 3 is only 1. So there's only one combination of all 3, which is 3 times 5 times 7. And then there are 3 combinations of 3 times 5, and then 3 times 7, and 5 times 7. And further, the number of multiple, like the sum of the multiples. So it's not just the number of multiples, but the sum of the multiples. So the when you're dealing with multiples of 3, if you're going to take the sum over all the multiples of 3, the count of the multiples of 3 is going to be, like, let's say 1 through 9. It's going to be 3, 6, and 9. There's only 3 of those, so 9 divided by 3 is 3. There's 3 of those, but we're adding each of those numbers, so the sum from 1 to 3, and then scaling that by 3. So it's going to be 3 plus 6 plus 9, which is going to be equivalent to 1 plus 2 plus 3 times 3, which the 1 plus 2 plus 3 is this part, and then times 3 is here. And this, I think, is x plus 1. It's x times x plus 1 divided by 2 is the sum from 1 to n. Or n times n plus 1 divided by 2 is the sum from 1 to n. Which is very similar to n choose 2, but it's not quite n choose 2. It'd be like n plus 1 choose 2. Yeah, so that's why. So you would scale these by the amount you're multiplying it by. Or you scale it by that base. Which I think is correct how this works. This is a more general solution beyond, like, you could do a more brute force solution, but this is a more general approach with a runtime error. Okay. Oh. Oops. Okay. I think I made a mistake there. Okay, yeah. That, I think, is correct more generally. What are some of the numbers that they have here? 1,000, okay. Let's go up to 1,000. Let's do like 599 or something. So, like, you can make n very, very large, and this solution that I just gave should work. Okay, I'm gonna go for it. I could be wrong. There could be a mistake somewhere in here, but I think this is correct. Yeah, okay, we're good. So, yeah, it's like technically a constant time solution for that specific. Tay just came to say all the very best. Hey, what's up, Quick Code? How you doing? I appreciate that. Thank you. Thank you. That's very kind of you. How's the stream health? Looks okay. Looks okay. All right. So next. So yeah, that's like a general solution to a question of that nature. Inclusion exclusion principle. Count the digits that divide a number, given an integer num. Oh, this one's already solved. Okay. Turn the number of digits in num that divide num. Okay, well, this isn't too hard. Yeah, you could do this very directly. This is you obviously have to figure out what the digits are. And then yeah, I mean, we could probably just code this directly. So we're gonna do int result 0, result. I was gonna say I already solved this one, but oh, actually, even easier would be maybe even easier would be like this. Something like this. Let's try this. Yeah, I think that's that. I think that one's very easy to program. I could be wrong, but I think it's very straightforward. Yeah, that's pretty good. That's pretty good. Yeah, I think that's okay. Okay. Given two binary trees, original and cloned, and given a reference to a node target in the original, the cloned tree is a copy of the original tree. Return a reference of this to the same node in the cloned tree. You're not allowed to change any of the two trees of the target node, and the answer must be referenced to a node in the cloned tree. What? What? What are they looking for here? Two binary trees, original and cloned, and given a reference to a node target in the original tree. The cloned tree is a copy of the original tree. Return a reference to the same node in the cloned tree. Not allowed to change any of the two trees over the target node, and the answer must be referenced to a node in the cloned tree. Huh. Target is 3. Number of nodes in the tree is between 1 and 10,000. Values of the nodes of the tree are unique. Okay, target node is a node for the original tree. It's not. Repeated values in the tree are allowed. Probably not. How would you do that? There's repeated values. Like, I mean, I guess you could. Well, how would you know which? How would you know which one is the target if there's repeated values? I mean, I guess you could do if there's repeated values, but like, what would that even mean? I don't really know what they want for this, but I guess you just do an in-order traversal. I don't know, man. It's a little bit odd. Okay. All right. I mean, quite frankly, you just did the cloned one. I don't think it even matters. Oh, there is a reference. Wait, yeah, but what? Oh, yeah, you can do this. Okay, if you get a target node, then then you can do multiple values. You just have to follow. We'll do it this way. Original, or we'll say, let's say T1, T1, T2. Here's how you do it for if there's multiples. So if T1, so if not T1 and not T2, let me just return a null pointer. Let's do it this way. Okay. Original cloned. This is going to hit the target. So we just say, if not T1 and not 2, return. Otherwise, we're going to say in order traversal. So we're going to say R of the left side, to left, to two left, and R of the right side, to right, to two right. And then we say if T1 equals target, then we're going to set result equals I don't know if I can use dereference like this. I might be able to, I'm not sure. Then we set the result and terminate early, but we set the result to T2, I think. I think it's that simple. It's something like this. Should return a value. Yeah, this should be. If I'm going to do it this way, then this might be a better approach. Compiler, of course. I'm going fast. Sometimes I make mistakes, man. I'm going to go for it. I think that's right. Let's see. How's the stream health? It's okay, I think. Oops. Ooh, okay, yeah, it's pretty good. Slow, but it's correct. Yeah, this works for there's like a way to terminate early, I guess. Let's add that so to kind of speed things up a little bit. Result. How to terminate early here. Nope, not much faster. Okay. All right, we'll go to the next one. Decode the message. Given the strings key and message, which represents a cipher, key, and a secret message, respectively, the steps to decode message are as follows. Use the first appearance of all 26 lowercase English letters and key as the order of the final substitution table. Align the substitution table with the regular English alphabet. Each letter in message is then substituted into using the table. Spaces are transformed themselves. For example, given key equals happy boy, actual key would have at least one instance of each letter in the alphabet. We have the partial substitution table of HA, AB, BC, YD, BE, OF. Turn the decoded message. The quick brown fox jumps. V lazy dog. A, B, C, G, okay. Jumps over the lazy dog. Key, message. Output, this is a secret. The diagram above shows the substitution table is obtained. Okay. Key length. What? Alright, we got a key and a message. Cipher key and a secret message. To use the first appearance of all 26 lowercase English letters in the key as the order of the substitution table. Align the substitution table with the regular English alphabet. Each letter and message is then substituted using the table. Spaces are transformed to themselves. Okay. I think I understand. So we're going to just say like table. Maybe it should be chars. Char ch and key. Table. So if fill table. I think we just fill these with like zeros or something. Table char constant index. I'm going to say table index is not equal is equal to 0. Then we'll update it. Actually, it's actually going to be ix is going to be 0 or current index. Yeah, we actually want two things here. It's only the first instance. So I've seen a little awkward, but this works. So table of ix is going to be table current index is going to be equal to this character. And then increment that current index. A little bit odd. I just don't know. Excuse me. Have a string result. Const char ch in message result dot push back table of ch. Something like this, I think, is what they want. Something along these lines. Stream health. Runtime error. Okay, not quite. Index out of bound. Alright. Spaces are transformed themselves. Oh, I see. Okay, got it. If ch is not equal to a space. Okay. Let's go with this here. Wrong answer. We have the, oh, oh, okay, wrong output. I may have like inverted the thing, I guess. Oops. Yeah. So I think it's supposed to be the other way around. It's going to be current index plus a. CH minus a. Something like this. It's confusing. Yeah. Alright, I'm going to go for it, see how it goes. I probably could optimize this a little bit, but I don't think it's totally necessary. I just kind of slightly misunderstood the question, I think. Okay. How are we doing on, okay. Yeah, we'll go to the next one. How are we doing on time? 2 hours and 22 minutes, okay, that's pretty good. Alright, number of steps to reduce a number to 0. Integer none, turn the number of steps reduced to 0. 1 step, it's even, divided by 2, otherwise subtract 1. Okay, so we just simulate this. This is always going to be logarithmic, basically. Any numbers will be quick to simulate. So int count is 0, return count. 4 0. Let's say count. If num1, otherwise num shift by 1. Yeah. That's a pretty quick one. That one, there might be a more direct solution. Let's see if the memory can be a little bit better. There might be a more direct solution, but because it's basically logarithmic, you don't really need to find something better. So this one's a MySQL question, which I'm a little more familiar with. Okay. Let's see. Okay. What do they want? Sale on the product in the current certain year, prices per unit. So there's a sales table, a product table, write a solution report, the product name, year, and price for each sale ID in the sales table. Return the resulting table in any order. The result format is in the following example. So sales table, product table, output, product name, year, price. Okay. There's product ID, product name, the year, quantity, price. I just want the price, I think. Product name, year, and price. So I think you just join on the product ID in these two tables, and then you get the product name as well as the year and the price. Yeah, I think it's that simple. So we're going to join on, good natural join, I think. So that's sales and product. Select from sales, natural join, product. What does this do? Let's just see what happens if I do this. Stream health is good. Okay, see if there's anything else. Output. Product name, year, and price. I think that's all I need. Year, price. Is that it? I think that's all. Yeah, that's pretty straightforward. That was not too bad. If you know what a natural join does, that's pretty straightforward. Construct smallest number from di string. You're given a zero index string pattern of length n consisting of the characters I, meaning increasing, and d, meaning decreasing. Okay. So I and d, smallest number from di string. Okay. Zero index string num of length n plus 1 is created using the following conditions. Num consists of the digits 1 to 9, where each digit is used at most once. The pattern. Oh, only 9 digits. Okay. Pattern I is equal to I. The nums of I is less than num of I is less than num of I plus 1. Pattern ID. Num of I is greater than num of I plus 1. Lexicographically smallest possible string num that meets the conditions. Okay. Oh. Interesting. Lexicographically smallest string. Smallest possible string. This is a puzzle, huh? Pattern's only length 8. I and D. Okay. Interesting. D. So it could be n plus 1 is the number of. Alright. Okay. Excuse me. So I think we want the smallest possible. Interesting. I'm not sure actually now. So for increasing, we can start from 1. And then when we're decreasing now, so 1, 2, 3. The third one is tricky because the D, actually you gotta have to look ahead. So the I's you could start at a lower value, or the lowest value. The D's though you have to increment. So this is not so obvious. It's a bit of a puzzle, huh? Nine factorial is a lot. I have to check how much that is, because you could do that too. Let me see if I can figure this one out. Nine times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yeah, I mean, I could just go through every possible. I could just go through every possible string and see if it matches this pattern. That's probably the easiest way to go, quite frankly. Every permutation. I'm gonna do that one first because it's easier. I think I can do that. Hmm. Nine element set. Efficient that be. Um. Huh. I'm actually not sure if it'll be fast enough. I think it'll be fast enough if I do that. So we're gonna do while. There might be a better way to do it, but this is simple enough. Um. Yeah, we're just gonna say possible. Um. Okay. Hmm. Um. Um. The pattern size is 2. This would be 0, 1. Yeah. Plus 1. You'll truncate. Okay. We're going to say check equals. Okay. So we're going to say and. What do we say the pattern was? It's got to be possibility index. So increase means it's got to be like this. And the other one is decrease. Oh no. Yeah, increase and the other one is decrease. Something like this I think works. I'm gonna give this a shot, see how it goes. I'd rather not spend too much time trying to figure out, like, there are other elements of this to figure out, I guess. I don't know that I need. I might be missing something important here. Wrong answer. Okay. Huh. Okay. Hmm. Um. Let's just do a quick check. I'm missing something here. Yeah, I mean, the issue here is that this is just like a lot of, like it's a puzzle. Would require a lot of like thinking, I guess. Um, it's kind of unnecessary to think all this through. Okay. Yeah, I mean it's going. So somewhere in here should have been 1, 2, 3, 5. Hmm. There we got the 1, 2, 3, 5s. So what did it say? 1, 2, 3, 5, 4, 9, 8, 7, 6. 4, 9, 8, 7, 6. Four, 9, 8, 7, 6. There you go. 1, 2, 3, 5, 4, 9, 8, 7, 6. Hmm. Um. Nums of I is less than nums of I plus 1. Oh, I know what's wrong. I totally forgot. That's subtle and important. Missed that. There we go. This is very expensive in terms of time, but it works. I think it might be just because of the printing. Let's try again. Yeah, like I said, there's probably a way to do this that's more efficient based off of like the puzzle, but um, it's probably fine to do this. So, oh, there we go. Solved it. Not bad. Give me 1 minute here. My computer's low on battery. Yeah, so like this is a fast way to program this. Like it's a fast way to actually code it. It's not an efficient solution. I think there's probably a solution that's a lot more efficient. But this like is easy to understand and it's easy to program it under like time constraints. So like we're trying to go quick here. Yeah, there might be a better way to think that if I think this through a little bit more, there's probably a better way to do this though. So not the best solution, but like a working solution allows me to move on to the next question. I would guess that there is a better way to do that. All right, let's look at stream health. Seems okay. Yeah, let me go ahead and just do something quickly here for a minute. Yeah, I'll be back in like 30 seconds. 30 seconds. weighted word. Okay. Um, so for the weighted word mapping, let me see. Given an array of strings words, where each string represents a word containing lowercase English letters. You are also given an integer array of weights of like 26, where the weights of I represents the weight of the ith lowercase English letter. The weight of a word is defined as the sum of the weights of its characters. Each word take its weight modulo 26 and map the result to a lowercase English letter using reverse alphabetical order. 0 to Z, 25 to A. Turn a string formed by concatenating the mapped characters for all words in order. Wow, what? What? Excuse me. So we have some words with some weights, and then we want to get Rij. The weight of A, B, C, D is this 5, 3, 12, 14, and take that modulo 26, which maps to R. Oh, that's confusing. All right, this is not too bad. Okay. String result. It's just gonna say words.size. Return result. Say for int I0 words size. I'm gonna say for const char ch in words of I. Say sum count or amount. I'm gonna go with amount. It's gonna be weights of char minus a. And then we're going to say result of I is equal to amount. Say it's going to be amount mod 26, I think. And that's going to be 26 minus it's amount minus 1. Something like this. Yeah, something along these lines. What are the weights? Excuse me. Weights are between 1 and 100, so the words are between 1 and 100, the length, so it's only going to be like 1,000, so I don't need to worry about overflow errors or anything like that. Looks like this is correct. I'm just going to go for it, see how that goes. It's probably right. Yeah, not too bad. All right, next. Just go quick. Stream's still alive. Yep. Filter elements from array, give an integer array, and filtering function, return a filtered array. Takes 1 or 2 arguments. Number from the array, index of the array. You contain the elements of the array. Expression is truth without the built-in. All right. Result for let index in array return result if array of function of array of index, then we're gonna say result push array of index, something like this. Excuse me. Okay. First index I is 0. Uh, What? Oh, huh. What? Takes one or two elements, one or two arguments. What? Okay. Well, okay. False? What? What? What is happening? JavaScript? Oh, JavaScript is something, huh? There's something weird going on here. All right. Tell me what's wrong. Tell me what's wrong. When ix is 0, why does the ix equal 0 or false? Stream health is good. Ix and 4n is a string, not a number. Why is it a string? Wow. Of entries. Interesting. Okay. Of course it is. Oh my gosh, man. Index value. Oh, JavaScript. Oh, JavaScript. 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 Yeah, JavaScript's always a peculiar one, huh? Yeah, I wasn't ready for that. The 4 index value is going to be a string, not a an integer. Like, of course it is. Of course it is. Oh, gosh, JavaScript is something else. Is this another JavaScript question? It is. Oh my gosh. array reduced transformation. There we go. Excuse me. Without using the built-in array reduce. Okay. All right. It's just an iteration, right? So that result. Oh, but this is its initial value. Then we're gonna say for let ix val of numset entries turn result. And we're gonna say this function takes. Okay, got it. Result and nums of whatever. Result and val, I think. I think that's it. It's a pretty straightforward thing. Yeah. Okay. Stream health team seems good. All right. Pretty good. Yeah, it's a very straightforward one. I mean, that one's pretty easy thing. Here we go. Okay. More C++. Give an integer array nums of size n for each index I, where 0 less than or less than n. Define a subarray nums start to I, where start equals max 0 I minus 1 I minus nums of I. Total sum of all elements for the subarray defined. What? What? 2, 3, 1 explanation. Subarray 2, 0, sum is 2, 2, 3 is 5, 1, 2 is 3, 1, it's 4. What is going on? What? What is happening? What? Each index define a subarray. Nums start to I, where start is the maximum of 0 and I minus nums of I. So, if nums of I is large, nums of I is large, total sum of all elements from the subarray defined for each index of the array. Oh my gosh, that's confusing. Well, anyway, you could use prefix sums to do this quickly. It's just keep it simple, I think. Yeah. So stood vector int. Let me see if there's could reuse this memory too. It's only 100. Okay. So we'll statically define this. Static stood vector prefix 101 prefix clear. Actually, I don't need to do that, quite frankly. Stood partial sum nums.begin nums.end prefix.begin thing 0. I don't know if I even need that. And then now we can say for result. What are we doing on time here? Okay, I still have another hour. Okay. Int I is 0. I is less than nums size. I Constant lower bound is going to be stood max of 0 I minus times y. It should probably be this one. Add an extra element there. And then this little plus equals prefix. Minus prefix. Which is going to be I to lower. And this I think doesn't include the position at I. Actually, I have to double check how this works. Prefix of I is going to give you the sum of the first I elements, I think. I think that's how it works. Wrong. Slightly wrong. Hmm. Excuse me. I mean, you could also just do it this way. I think this also works too. Yeah, that's fine. This is like a slightly different way of doing this. This isn't the most efficient way to do it, I'm sure, in terms of memory, but it's definitely reasonable. Yeah. I wanted to do something like this, which would actually give me, I think, do +1 here. Yeah, that's what you do. Yeah, I like that solution a little bit better. It's a kind of a different way of defining the prefix sums. All right, how are we doing? Time. It's 3 hours. Okay, not bad. So let's go to the next one. Yeah, prefix sums pretty good. Prefix sums are pretty good. Okay, count good triplets. Given the array of integers array and 3 integers ABC, you need to find the number of good triplets. Triplet is good if the following conditions are true. The first and second is less than or equal to A, the second and third is less than or equal to B, the absolute difference is B, and then the first and third, the absolute difference is less than or equal to C. Okay. Oh, well. Oh boy. Okay. So, I mean, there are probably various ways to do this. I think if you sort it, you could do this in n log n time. I know I could do this in n cubed time, but n log n time seems okay too. Hmm. You could probably sort and then binary search on A to figure out how far you can go for B. I'm actually not really sure about this, quite frankly. This is really awkward. I think there's probably a way to do this more efficiently, but we're just going to brute force it. Keep it simple. We're just going to keep this one really simple. X, Y, and Z. I think you gotta actually do I mean, I think this is fine. Just a simple triple loop. And then we just say, like I said, there's possibly a better way to do this, but for now it's simple enough. So yeah, I think this is fine. It's X minus Y, and it's Y minus C, and it's what is that? X minus C. Yeah, I mean, there's probably a more clever way to do this, but just going quickly, this is probably the easiest way to go fast. Yeah, let's just go for it. See how this goes. Still one of the faster solutions, even though it's still a relatively fast solution, even though it's kind of inefficient. We'll do one more check. 1, 2, 3, 4, 5. There's probably a way to do that that's a little bit better. That's okay. All right, product ID, store 1, store 2, store 3. Solution: rearrange the products table so that each row has product ID, store price. If a product is not available in the store, do not include a row with the product ID and store combination of the result table. Return the result table in any order. Result format is in the following example. It's products, and this looks like it's a pandas question. No, it's a MySQL question. Okay. Products table. Store. Oh yeah, this is like a melt routine again. Yeah. Okay. And you could use pandas for this, I guess. Could use pandas for this. Might be easier. This is just a melt routine. I gotta sneeze. This is Store price. So this is like var ID or something. ID var is var name, value name. Something like this. Comma. Done that before. What's chat doing? What's up, chat? I wrote a poem. Want to hear? What's up, man? Is it good? If it's not good, I don't want to hear it. If it's not a good poem, I don't want to hear it, man. Give me a rating. Tell me how good your poem is on a scale from 1 to 10. If it's not like a 7 or an 8, I don't want to hear it. All right, we gotta just remove the nulls. Pandas melt, remove null values. There's probably a few different ways to do this. Chain drop NA. Okay. Subset value. Dot drop NA. Okay. Price. It's not gonna work out. Oh, it worked. I was like, that's not gonna work out. It worked. Okay. Let's try again. All right, let's go for it. Yeah, it's a little bit easier with pandas now that I've practiced with that a little bit. I'm sure I could do that with MySQL as well, but that would be more involved. Significantly more involved. Let's see, stream health. Stream is healthy. Got another 50 minutes here. Let's go to the next one. It's an 8, I guess. I got rejected by my first love, so I wrote as my way of respecting her, moving on, yet not forgetting about her. Huh. Interesting. Dude, I would forget. I shouldn't say that. I'm pretty cold though. I'm pretty harsh when it comes to dealing with loving and losing. Not even loving and losing, just loving in general. Just I don't know. I shouldn't say that either. It's an 8. All right. Let's listen. If it's an 8, if you say it's an 8, that's pretty reasonable. What can I say about that? Sorry I got rejected, man. That's a bummer. I am yeah, I'm the kind of guy who, like, I just want to forget it and move on when things don't go well. Like, I like to learn from things, but like beyond the learning, I'm just like, ah. All right. 0 index integer array nums and a positive integer k. Apply the following operation on the array any number of times. Choose any element of the array and flip a bit in its binary representation. Flipping a bit means changing a 0 to a 1 or vice versa. Return the minimum number of operations required to make the bitwise XOR of all elements of the final array equal to k. Excuse me. Note that you can flip leading 0 bits in the binary representation of elements. For example, for the number 101, you can flip the 4th bit and obtain 1101. Okay. Following operation on the array any number of times. Choose any element of the array and flip a bit in its binary representation. Okay, so it's an array of numbers, and I'm flipping a bit. Okay. I can do this any number of times. Minimum number of operations required to make the bitwise XOR of all elements of the final array equal to K. Huh. Interesting. I think I can just take the XOR of the entire nums array and then take the XOR again with K and then take the pop count of that. I think that's it. So we're going to do return std pop count. It's going to be bit set count. It's going to be int x. We're going to say std accumulate XOR with K nums.begin nums.end 0 std XOR. All right. How about this one? Unqualified ID. No. C++ XOR functor accumulate. I have to. I might have to do it this way. I might have to do it this way. Oh, bit XOR. Okay. All right, let's go. Go, 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 go. There. What? Oh. Let's try again. There we go. All right, I think that's it. I think that's the answer. Eyes that glitter in the darkest of hours, how could I not crave your radiant light? Even in the sun, you shine the brightest, a beauty unmatched, a soul-stirring sight. They say I remembered you only once, but truly you never left my gaze. I'm cold and ruthless now. I learned a lot too. I'm going to be badass now. Had an interview where they asked me what is an array in JavaScript, but I answered the array is in C++. I never got to hear from them. Oh, it's brutal, dude. Interesting. I like your poem. That's about right, dude. That's the way to be. So this isn't even the best solution. You gotta be kidding me. It's not even the best solution. This is such a good solution. This is such a fast solution. What do you mean this isn't the best? This is like so optimal. Oh my, I can't believe it. What's going on? Why is this so slow? I'm annoyed. I'm annoyed. This should have been like super fast solution. All right, whatever. Whatever, man. Whatever, man. All right. Okay, 91%. I'll take it. I'll take it. I'll take it. All right. But you didn't. What? Hold on. What? Oh, I'm starting to buffer a bit here. Use dark mode. What's up? I kind of don't prefer dark mode, actually. Believe it or not. Believe it or not, I don't always like dark mode. Although I can understand why people watching would be like, "Oh, my eyes." I don't know. What do you think? Let's see. Okay. For a live stream, how many people, percentage wise, prefer dark mode over like. Okay, there you go. Asked you an array in JavaScript. Answered the arrays in C++. Never heard from the back. That's rough. I actually wouldn't know how to answer that. Like, what's the difference between a C++ array and a JavaScript array? I would fumble that. I mean, I would know some of it, but I wouldn't know the whole thing. Because JavaScript arrays are a little weird. They're very weird. They're like objects or something. They're very odd. Everything in JavaScript is odd, man. In my opinion, JavaScript's a weird language. All right, zero indexed integer array nums of even length, and there's also an empty array. Alice and Bob decided to play a game where in every round Alice and Bob do one move. Rules of the game are as follows: every round, Alice removed the minimum element from nums. Bob does the same. First Bob will append the removed element in the array. Then Alice does the same. So Alice removes one, Bob removes some. Bob adds it back, Alice adds it back. Okay, the game continues until nums becomes empty. Return the resulting array. Okay, it's an even number. All right, but I think it's going to be, they remove one, push one. It's going to be like a queue. It's going to be if you reverse all the elements and then reverse every two elements, swap every two elements, I think. I could be wrong, but I'm going to try it. I'm actually going to try this, see what happens. I could be, something tells me this is what happens if I do this. Wait, that's my intuition, my spidey senses are tingling here. Let's go for it, see how it goes. Oh, 82.9% of Twitch viewers use dark mode. Oh, 73%. Oh man, okay. Strong majority preference for dark mode. All right, you win. You win. Dark mode. Gotta give the people what they want. Advanced. Hold on, let me. Can I? There should be a button somewhere on here. Dark mode, right? Where's dark mode? LeetCode, dark mode. Go with dark mode. Oh, it's the wrong answer. Okay. 5, 4, 2, 3. Wait. What? Oh, yeah. So, okay. So Alice takes a 5, Bob takes a 4. Then we get 4, 5. Wait, how come? What? Oh, the minimum element. Oh, okay, that's my mistake. Okay, got it. Okay. It's got to be sorted first. So 2, 3 is what they take first, and then they push 3, 2. Oh, okay. All right, try this one. Slightly different. Possibly correct. There we go. That's probably right. I'm just gonna go for it. I didn't prove that or anything. I just thought about it. Oh, what do you mean it doesn't have a dark mode? Oh, LeetCode doesn't have a dark mode. Dark mode. Oh, appearance settings. Freaking LLMs, man, they're so dumb. They're like, no, they don't have one. Like, what? What? Okay. How do I access it? Where are the appearance settings? You ask it a simple question, just gives you the wrong answer. Sweet. So that was right. Nice. We'll submit one more time. Somewhere around here. I'm pretty sure there's a button somewhere around here where I can do dark mode. Layouts. No. Notes. No. No, no, no. Settings. Dynamic layout, code editor, shortcuts. Advanced. This is killing me, man. Where? Go next question. We're trying to figure this out. I don't see. I might have to go here. Features. I gotta subscribe. Arithmetic triplets. Array in JavaScript is a special object in C++. They are a data structure that store homogeneous elements in contiguous memory location. In JS, you store elements of any data type in the array. You're right. You're right. My language is like C++. It needs the data type. Needs to be the same. Ever get bored by doing coding? What's up, Sabro? What's up, dude? No, not really. I wouldn't say that. I actually really like coding a lot. I get bored having to do all the other stuff I need to do in order to code. That's what bothers me. All the other stuff is boring. Oh shit. Okay, we got it. Get profile avatar, hover over appearance, click dark mode. All right, profile avatar. Appearance. Oh, beautiful. There you go. Ooh, how you like that? BEA, beautiful. Oh, there you go, buddy. Hope you all feel better now. Hope you all appreciate that. I already appreciate it. I'm already appreciative. All right. So you're just okay. Strictly increasing integer array nums and a positive integer diff. Triplet is an arithmetic triplet if the following conditions are met. So nums of their I is less than j is k. Nums of j minus nums of I is diff, and nums of k minus nums of j is diff. The number of unique arithmetic triplets. Okay. All right, so if diff is 3, so 0, 3 doesn't exist. 1, 4, 7 exists. 4, 7, 10 exists. And so this is kind of straightforward. I think using a frequency map is probably the easiest way to go. Could use a hash map. Ooh. And fortunately, the numbers are bounded, so this can be done fairly efficiently. Come back to this in a moment. I like coding as well, but it's frustrating when there's one bug that I have no idea comes up. Yeah, that's a tough one. Give me 1 second here. Static frequency 201. And we're gonna say fill. Talk about bugs in a second. Bugs in a moment. Const int x nums frequency of x plus 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 plus, and then we're going to say for constant x nums result. When it comes to bugs, logging, lots of logging. That's what you want to do. Log the heck out of everything. You can run through your logs and say result plus equals. It's going to be frequency of x times frequency of x plus diff times frequency of x plus diff times 2. Yeah, I think that's it. It's that simple. Because it's going to be zeros if those things don't exist. Okay. Required. Oh. That's important. Important to do that. Compiler. Also maybe important for that one too. Okay, how do we do? Yeah, that's good. That works. Oh no! Brutal. I made a mistake. I done goofed. No, I got my first error in like, I don't know how many bits of code. What? What did I do? Wait, what? What? What did I do wrong here? Hold on. Fatality. Oh, my first error in like, I don't know how many programs. What did I do? Speaking of bugs I don't know about. Oh, index 201 is out of bounds. Oh no. Oh, I goofed. Oh, I goofed, man. Oh, I didn't think about that. Oh, that's a pretty subtle one. Yeah, I made a mistake. I made a mistake. Oh, I made a mistake. Oh, I mean, there's a few ways to handle this, but yeah, I'm going too fast, but I just didn't look at it. You could do that really quick. It's not that I was going too fast. I just didn't think about it. Oh, they got me, man. They got me an easy question. They got me an easy question. I got wrecked, dude. I got wrecked. All right. This is why you practice. This is why you practice. Shame. 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 I wouldn't say it's a shame. It's just what it is. That's just the reality of programming. It's that you know how it works is that your brain doesn't know everything, and the only way to figure out if you're wrong about something is to try it. And your brain is like, "Hey, that's wrong," and then your brain fixes in the mind, and that's the only way to learn. It's literally the only way. Literally the only way. Given a string S integer array, indices of the same length, the string S will be shuffled such that the character at the ith position moves to indices of I. The shuffled string return the shuffled string. Okay, an integer array of indices of the same length. Okay, so it's a permutation. Right. So we're just gonna, excuse me, we're just gonna write a permutation. This is gonna be dot size a, and then we're gonna say for I 0 indices size I return result. Say result of indices of I is equal to S of I. Is that right? I don't know. I have to double check what they mean exactly. Yeah, that's what they want. I'm pretty sure that's it. Let's go for that one. What do you do? I'm still in college looking for internship. I am giving interviews this time. They have this AI interviews the first clearing check. That's pretty interesting. Sucks. Yeah, I got wrecked, dude. I got wrecked. I got beat. They got me. Um, I worked on algorithmic trading systems for a while. Electronic trading systems for like fintech. I did that for like a few years, and then I quit. And I was looking for a job. I didn't find one. I was annoyed, so I just picked up random like work that I could find, and eventually now I work in like fast food, and it's not too bad. It's not great, but it's not too bad. Um, but I do want to get into some other stuff like tutoring, coaching, mentoring, and then I think later down the line I'll probably start my own company, my own software company, because I'm just kind of like I'm pretty annoyed with employers at the moment. It's pretty irritating, some of the stuff that they've been up to. Some of the things they've been doing is not no fun to deal with. Kind of annoyed. All right. Count number of pairs with absolute difference k. Give integer array a, integer k. Return the number of pairs ij where I is less than j, such that nums of I minus nums of j is equal to k. The absolute difference is equal to k. Okay. The absolute difference of 1. So there are a few ways to do this, but probably the easiest thing is just sort it. And a frequency map is nice here too. Yeah, I have to be careful though. Doing this again with frequency map. I got in trouble last time with the frequency map. All right. Frequency, what is this, 101? Yeah, it's 100, 1 to 100. Okay. Okay. Const int x nums. And we're going to say frequency of x plus plus. And then we're going to say, oops, I'm going to say 4. Let's do 0, 1, 100. Result. I think this works. What did I say the diff was? It's going to be frequency of something like this. Let's actually do if statements. So if x plus the difference, x plus k, it's less than or equal to 100. Frequency of x times frequency of x plus k. And then the side of x minus k is equal to 0. I think it's greater than or equal to 1, it should be. Same thing. Something like this works, I think. It's a little bit complicated. I think that works. Let's give that a shot. Facebook or Google. I was doing DSA and WebDev together, but I couldn't keep it, so I dropped DSA after completing the linear part in binary trees. Thought maybe I should get a job or internship first using WebDev. So I interviewed at Google like a bunch of times. I've thought about interviewing at Facebook just because I think the AI interview could be interesting. I have been learning a little bit about AI. DSA and WebDev. The most important thing for employment is one that you're going to work for cheap, Cheap. Gonna work for cheap. Oh, it should be I, not X. Oops. I made a mistake. The number one thing they want is they want you to work for cheap. So they want to take your money. They want to take your labor and not pay you nothing for it. So that's like the first thing they want. And then the other things they optimize for is wrong. Okay. So wrong. You said wrong answer. You get to 8 to expect a 4. Okay. So there's 1, 2. Oh, I think the reason why this is wrong is yes. So this is actually correct. And we don't want to do it this way, I think. Yeah, I think that's right. Okay. That's kind of subtle, but yeah. Yeah, okay, got it. It's pretty good. All right, we'll submit it one more time. Yeah, the biggest thing for employment is years of experience, your pedigree, which school you went to, and how cheap you're willing to work. And there's one more thing they optimize for, which I forgot. There's something else that they look for. Yeah, they want as much money they could squeeze out of you as they possibly can. What's the other thing? There's 3 things they look for. Years of experience, where you went to school, the top school pedigree, and then your skills, I think is the third one. Like role fit. I think it's the skills, the third one. I want to say it's the skills. But yeah, those are like the main things. They look for other stuff too, but that's like like if you have code that's public, that's really good. Like they like that too. But the biggest thing is that they can charge you a very small amount of money. They want to take as much money from you as they can. To be really explicit. It's kind of a dark and negative thing, but that's what they want, man. They're there to make money, and they're there to make money off of you. Basically, if you could make more money on your own, then they're gonna make some of that money themselves. That's the idea. So like you're like always losing if you work for an employer in software development. Pretty much. Unless you're like in a spot where it makes sense to do that. But that's kind of just the bottom basic rule. So that working for an employer is you're just always losing out. Not always losing out completely, but losing out to an extent, greater or lesser extent. Like they basically won't hire you if they don't think that you're gonna make more money for them than they're gonna pay you. In short, count items matching a rule. You were given an array items where each items of I is equal to type I, color I, name I, describes the type, color, and name. And in software development, it can be really egregious. Like there are people who brag about they make $500,000 a year, and you're like, oh, that's great, but they'll tell you they're like, yeah, I helped the company make like $500 million a year, or like $5 billion a year, or something crazy. And you're like, you made them $500 million, and they paid you 500,000. You don't think maybe you should ask for more money? Something like that. I don't know. Yeah, that's pretty rough. Given an array of items where items of I, type, color, name, describe the type, color, and name of the ith item. You're also given a rule represented by 2 strings, rule key and rule value. The ith item is said to match the rule if one of the following is true. Rule key is type and rule value is type. Rule key is color and rule value is color. Rule key is name and rule value is name. Okay, interesting. Return the number of items that match the given rule. So input, phone blue pixel, computer silver Lenovo, phone gold iPhone. Rule key is color, rule value is silver. So, okay. Color Savai. So if it's color and the second one is color and it matches silver, so one of these does match silver. All right. One item matching the given rule. This is a pretty confusing question. Rule keys are their type, color, and name. So basically, you just pick one of the three values of the tuple, and then check if it matches against the rule value. I think that's what's going on here. This is confusing, but I think it's not that complex. I'm going to keep this one simple. Just say result, const auto, v and items. We're going to say int index 0. We have a case switch statement. We're going to say switch on rule key. We're going to say case. What are the three things? Type, color, name. Okay. Type, color, name, default. And we're going to say, I maybe could make a map for this or something. Okay, switch statement's fine. I think the switch statement's maybe a little bit long. Index is 0, color I think is 1, and name is 2. And then we're just going to say result plus equals v of index equals value, I think. It's something like this. Oh, can I not switch on rule key? No. Oh, that's a bummer. That's a bummer. All right, anyway. It's fine. It's fine. Okay, we're gonna be just fine. Okay. How we doing here? Okay. Something wrong here. I very rarely use if-else statements. There we go. I think that's, I'm just gonna go for it. I'm pretty sure it's right. So let them build these AIs. As soon as they get better, I will replace these companies with one-man teams, super cheap engineers and services. Bastards deserve this. 3 a.m. here. I gotta go to sleep now. Bye. Good luck with the stream. We'll subscribe before leaving. I appreciate that. Thank you. Take care. Yeah, there's this great irony about they are going to replace all, like when they make the AIs really strong, everybody will be able to program whatever they want really efficiently, and so like the big tech companies will actually have a disadvantage because previously the advantage they had was that they had a lot of money, so they could pay people to program for them. They could basically bribe people to take their IP. To put it in really explicit terms, they could bribe people to give up their intellectual property. But now there's no reason to do that because people can program so much more easily that there's no reason to give up anything to the companies. So they're actually eroding. They're spending a huge amount of money eroding their own advantage, which is like peculiar. It's very odd. I don't know why they would do that. I don't know. I think they think that they're going to be able to like replace the labor that they're paying, but actually, what's going to happen is the labor is just going to move on and they don't need their money anymore. Basically, they won't need their money. So I don't know. I don't know. I guess I don't know what they're doing, but I don't think the big tech companies are going to be around as much in the future, quite frankly. I think they're going to get kind of wrecked by sort of the AI changes in the future. Okay, so all right, difference between element sum and digit sum of an array. You were given a positive integer array nums. Element sum is the sum of all the elements in nums. Digit sum is the sum of all the digits nums, so distinct that appear in nums. Turn the absolute difference between the element sum and the digit sums. The absolute difference. Okay, I mean this is a pretty straightforward one. The digit sums are less obvious. Compute that. Could use you could do something like this. Emulate nums again. Nums.end 0. And then this is going to be minus stud transform reduce. And this is going to be the digit sum. And we're going to have a nums.begin, nums.end 0, stud plus, and then constant x. Int result, or just dsum x is greater than 0, std equals 10, dsum plus equals x mod 10, and then return dsum. Could try something like this. Oh, it's the absolute value they want, which is a little bit different. Other yeah. And they want the absolute value of that. Okay, let's try this. Right, I have to remember not to. Gotta remember not to do that. Okay, let's go for it. Okay, not the most efficient though. How am I doing on time? I got another 10 minutes. Okay, I'm doing okay so far, I think. Minimum average of smallest and largest elements. Have an array of floating point numbers averages, which is initially empty, or given an array nums of n integers where n is even. You repeat the following procedure n over 2 times. Remove the smallest element, min element, and the largest element, max element, from nums. Add min element plus max element over 2 to averages. Turn the minimum element in averages. It's initially empty. Given an array, repeat the following procedure n over 2 times from nums and add this element to averages. The minimum element in averages. Interesting. Huh. I mean, you could do this by sorting it first instead of. What are what's the bounds in the numbers? Oh, they're really small, between 1 and 50. Okay. Yeah, okay. And then you can just do like int I 0 is less than nums size, which is 1, increment I, and then say This should be a float, but double result. This could be like 100 or something. It's going to be nums I plus 2. Got to convert this to a float. Nums, it's going to be nums.size. Si minus 1, a plus 1, I think. If it's like 0, 1, 2, 3, 4, 5, 6 elements. 0, you would do size 6. Yeah, it's minus 1. Divided by 2. I think that's it. Wrong. Oh, that's rough. 7, expected 5. It's the smallest and the largest. Add them together, divide by 2. Minimum element and averages. So 1 and 15, you get 8. Then is that 3 and 13 gives you 8 again. Then 4 and 7 gives you 5.5. Oh, I think yeah, I did that wrong. That was a PEMDAS error. That was an order of operations error. There we go. Okay. Yeah, that's one way of doing it. I think that's a reasonable way of doing it. It's maybe not the. It's okay. Yeah, it's okay. How are we doing on time? 5 minutes left. Okay. Rename columns. All right. Data frame students, ID, first, last, age. For a solution, rename the columns as follows. ID, first, last, age. Oh, okay. I mean, that's age in years. All right. I mean, that's. Could do this on my scale. Oh, this is pandas. It's gotta be pandas. All right. I don't know how to do that in pandas. Pandas rename columns. Yeah, I don't know the syntax for that one. I don't know the syntax for that one, man. I don't know it. I don't know it. I don't know it. Oh, I guess we're not going to know it either. Potentially. Let's see. Yeah, stream is okay. Stream health is okay. Oh, man. It's struggling, huh? Okay. I'll try one more time. LeetCode does have a dark mode, man. I found out that it does. I found out that it does. What is going on here, man? What is happening? What is happening? All right. This is taking too long. Pandas rename data columns of data frame. Jeez, man. Sometimes LLMs just get like hung up on various things. Rename function, directly assign rename function. In place true, rename is true. Okay, let's do students dot rename in place is true. True. And we're going to use this map ID, student ID. First to first name, last to last name, age to age in years. Okay, let's try this one. Runtime error. Return a data frame. Okay. Okay. Wrong answer. Oof. Output. Oh. What? Huh. Columns equals. There you go. That's probably it. I probably don't need to spend too much time. Oh no, uh-oh. Getting some buffering here. Let me see, let's check the stream off. So I don't need to spend too much time. Okay, we got like a minute left. Let's probably do one more question and then we'll be done. We'll do one more submission. So this has been fun. It's been interesting. Construct the minimum bitwise array 1. Given an array nums consisting of n prime integers, to construct an array answer of length n, such that for each index I, the bitwise OR of answer of I plus an answer of I plus 1 is equal to nums of I, i.e. answer of I or answer of I plus 1 is equal to nums of I. Additionally, you must minimize each value of answer of I in the resulting array. It is not possible to find such a value for answer of I that satisfies the condition and set answer right for -1. Example 1, nums 2357, -1, 143. I equals 0, as there is no value for answer of 0, satisfies answer of 0 or answer of 0 plus 1 equals 2. So answer of 0 is equal to -1. Okay, so I need to find some OR value, some answer that when I OR it with itself plus 1, I get 2. Okay, that's interesting. Smallest answer of I that satisfies answer of 1 or answer of 1 plus 1 is 3 is 1. 1 or 2 is 3. Huh. When you OR with itself plus 1, ORed with itself is just itself. When you add 1 to it, you basically flip all of the leading ones from the right to left, and you flip that 1 bit. And basically, when you OR this, you take the least significant 0 bit and flip it to a 1. So if you flip back, right, that gives you your answer from like 3, for example. Yeah. And it doesn't work if it's even. If it's even, there's no answer. Only works for odd values. Yeah. Because if it's even, there's no 1 from right to left. So you would just find from right to left, the bit that's a 1, from your sequence of 1s right to left, and you would flip that bit to a 0. And then if it's even, you just return -1. That's pretty straightforward. That's an interesting number. It's an interesting question. Oh, and then nums of I is always a prime number, so that means the only one that doesn't have this is 2. Okay. Cool. That's an interesting question. So std vector int result. Can actually just modify nums directly. It's probably easiest. So 4, 0, nums size I, nums of I 0 is 2, so I equals 1. Otherwise, find left the sequence of 1s. Actually do some bit manipulation. So int bitman, or just say bits. We'll just say b. Okay, b plus 1. So we're gonna XOR b plus 1. So if we add 1 to b, then we would flip all those bits to zeros and flip that 1 to a 1. Then when we XOR, no. When we add 1, we flip that bit, right? The answer is going to be that specific bit in no. In the answer, when we add 1 to the answer, we flip that bit. And then we OR them. We have the answer with all these 1s with that. Yeah, so actually you want that's got to be equal to b. You want to say b plus 1 and bit shift it by 1. And then now you've got a 1 in the right spot. And then you XOR this with oh, that's confusing, huh? Oh no, man. No, this isn't quite right. I gotta like really think about this. So from what we want, when we add 1 to it, we flip all those bits from right to left. And then we OR, we basically took all the 1s from right to left, and we added we flipped the least significant 0 bit. We flipped the least significant 0 bit. Okay. that gives us nums of I. So how do I flip that least significant? How do I flip that bit back from nums of I? Well, actually, you could just subtract 1. Oh, but it's the smallest one. Oh, yeah. Okay. So from right to left, if you add 1, right, and then bit shift that by 1, that's the bit that we want to flip to a 0, right? And then everything to the left, how about this? We add 1, we XOR, no. I want to isolate that bit. I want to add 1 and isolate the bit that's there. If I add 1, everything flips from right to left. If we AND, then actually that bit will dissipate, it will disappear. And I'll only get the left side, the mask on the left side. If I XOR, on the other hand, I'll get everything on the left side disappears, that bit stays, everything to the right stays. Okay. So let's do constant step 1. We're going to say B and B plus 1. No, B XOR B. That's going to eliminate everything to the left, keep the bits on the right that are 1s, and keep the extra 1. And then now, I can bit shift to the right, step 1, right? I can now bit shift to the right and add 1. And that'll give me the isolated bit. Yeah, that's what I want. Okay. Now that isolated bit, I can say nums of I is going to be B XOR step 2. There we go. Okay, confusing, but I think that's correct. Wrong answer. 7/7/15. What? So maybe it needs to be 2 bits. There we go. Okay, that's a little bit confusing, but I think that's right. There we go. All right. The reason why it's 2 bits is when I add 1, we get another bit off to the side, right? So there's the bit we want to remove, and then we end up with a 1 to the left of it and a bunch of zeros. Then we XOR, we end up with a 1, which is to the slightly to the left, and a whole bunch of 1s to the right, and we masked out everything to the left. Then we add another 1, we get another bit over. So now it's 1, but now we gotta move back twice to get the actual bit we want to remove. That's very confusing, but it works. So there you go. That's going to be the last one for today, I think. It looks like the stream did stabilize, though, towards the end there. Pretty far over 4 hours here. Let's see if there are any. Just sleep, bro. What's up? What's up, Priyanshul TD? Hope your day's going well. Welcome. Yeah, this ended up being quite a bit more complicated, but it worked. We got it. But I'm actually not that tired right now. I got some sleep last night. Um, but yeah, thank you for watching, everybody. I hope you guys have the rest of your day, rest of your night, and I think we'll stop here. It's been pretty good. That was pretty reasonable sequence. Thinking what else to say before I go. I think I'll just say goodbye. So yeah, thank you for watching. If you like the stream, don't forget to subscribe and like and all that. Comment and whatnot. Um, yeah, I'll probably be streaming more frequently in the future. We'll see. I'm kind of trying to decide what I want to do exactly. But I appreciate you all coming by and saying hello. I appreciate that. So yeah, have a good rest of your day. And those of you that need to sleep, get some sleep.